Hey guys, welcome to this video on differentiation for level 2 calculus. Alright, so we're going to be covering the basics of differentiate. So I'm just going to basically how to differentiate given a function. So basically if we have a base to a power and we differentiate, we're going to bring the power down. We multiply the coefficient by the power, but then we take the power down by 1, okay? So this might look a bit complicated right now, but when we get to the actual differentiating, you'll see it's not that hard. So the purpose of differentiation is to find the gradient function. This means we can substitute any x point into a gradient function and it will tell us the gradient at this point. So basically how much is that graph increasing or decreasing at a certain point, okay? Because not all of the graphs are increasing or decreasing at the same rate. Like sometimes a parabola could be decreasing at this much, but another place it could be decreasing at a different amount or increasing. So the power goes down, so therefore if we differentiate a cubic, it will become a parabola. If we differentiate a parabola, it will actually become a linear graph. And in most questions, like 99% in this exam, the first step is always to differentiate or integrate. So in this calculus exam, so basically like 99%, you're just going to be doing the skill. This is going to be a repeated skill that you need to know. And basically, I have some pictures here. So if you have a cubic, that will differentiate to a parabola, and if you have a parabola, that will differentiate to a linear graph. Alright, so I'm doing some practice differentiation. So for example, you have 2x squared plus 6x plus 9. So that will differentiate to, if you multiply the 2x squared, if you multiply the 2 by the 2, you'll get the 4x, and the 6x, basically it's x to the power 1, so 1 times 6 is still 6, but then you take the power down by 1, so the 1 becomes a 0. Anything to the power of 0 is 1, so 6 times 1 is just 6 by itself. And the 9 just disappears. The reason the 9 disappears is because you can write it as 9x to the power of 0, and therefore 0 times 9 is 0, so therefore it just disappears completely, so you just don't have to account for that anymore. And number 2, 3x cubed plus 9x squared plus 12x plus 8,992. So I've exaggerated a little bit, but I'm just trying to make the point that no matter how big or how small the one without the x's, it still disappears no matter what. And I've looked here, I forgot about the plus 12. Dang it. So guys, if you're watching, it's 9x squared plus 18x plus 12. Sorry about that. I forgot about the 12x. 7x to the power of 8 plus 6x to the power of 4 plus 3x plus 10. And that differentiates to 56x to the power of 7 plus 24x to the power of 3 and plus of 3. Number 4, a half of x cubed plus 2 over 3 x squared plus x plus 8. So in this case, you just do the exact same thing. So 1/2 times the 3 will be 3 over 2, and you just take the power down. So basically, if we differentiate, that will become 3 over 2 x squared plus 4 over 3 x and plus of the 1. Alright, so that's just basically the basics of differentiation. So that's a basic skill that you need to know for the standard. So number 2 is rearranging. Okay, so some of these equations do need to be rearranged before you can differentiate. So what I mean by that, I'm going to bring up an example. So example would be y equals to the square root of x. So right now you see we don't have a power, so therefore we can't actually use our power rule to differentiate. So in this case, we're going to have to rewrite this square root of x as x to the power of 1/2. And most of these rearranging does require some algebra skills. So you do need to be understanding some of these algebra rules before you can rearrange. So y equals the square root of x. So you can in this form you can't differentiate like I just mentioned. So we can rewrite this as square root of x is actually equal to x to the power of 1/2. And if we differentiate that, it's just the exact same thing. So you bring the power down, it becomes 1/2 of x, and you take the power down by 1. So if you differentiate that, that will give you a dy over dx. So that's just dy over dx. What is that? That's just a notation for the differentiation of a function, okay? So if you have y equals to something, then your gradient function will be dy over dx, okay? So that equals to 1/2 of x to the power of negative 1/2. And I've got the 2 graphs here. So the red line is the square root of x, and the green line is the differentiation. I've looked at a few examples. So we had the third root of x squared. So once again, we're going to have some algebra skills. We're going to rewrite this as x to the power of 2 over 3. Rewrite with power, yeah. So it's x to the power of 2 over 3. And once again, we just differentiate normally. So that becomes 2 over 3 x to the power of negative 1 over 3. So you take the power, you multiply first and take the power down by 1. So 3 divided by x to the power of 2. So once again, using our algebra skills, we can move the x to the power of 2 up to the numerator, but reverse the sign of the power. So positive 2 becomes negative 2. So 3x to the power of negative 2 is what it becomes. And therefore, now we can differentiate just the exact same steps. And that actually becomes, so if you do negative 2 times 3, that's negative 6 to the power, negative 6 x to the power of negative 3. And you can move the x to the power of negative 3 back into the denominator by making the power back to a positive. Okay, so just a bit of algebra. So negative 5 divided by x to the power of negative 3. So once again, you're going to rewrite this, bring the power up to the numerator, and differentiate normally. Negative 15 x to the power of 2. And finally, we have 3x to the power of 2 divided by 2. So we're going to move the 2, it's basically just rewriting this as 3 over 2x squared. And once again, we can differentiate normally. We should get 3x as our answer. Alright, so that's our differentiation over. Okay, that's basically all we need to know for how to differentiate. So now our first skill is finding the gradient at a point. So basically, our steps in order to find the gradient at a point is number 1, differentiate, and then substitute x value and solve for the gradient, okay? Okay, so basically, if we, for example, we have this graph, and we want to find the gradient x equals to 2. So I've marked the x equals to 2 and at the graph. So if we differentiate this, we'll get a linear graph, and this linear graph will tell us the gradient at x equals to 2. So as you can see, when x equals to 2, the gradient is actually 12. So therefore, we can conclude that on our parabola, when x equals to 2, the gradient was 12. 3 practice questions. So find the gradient of the curve f of x equals to 2x squared plus 3x minus 9 at the point x equals to 2. First step is to differentiate the function. So our f dash of x, so f dash of x, what I'm saying is that actually means just f dash of x is one differentiation from our function, okay? So each dash represents a differentiation. So for example, I have f double dash of x. That means our function has been differentiated twice. Alright, so back to our question, we have f dash of x equals to 4x plus 3. And we want to find the gradient at x equals to 2. So simply, if we substitute 2 back into our f dash of x, we can find our gradient. So if we substitute x value and solve, that should give us gradient should be 11. And I've got a few graphs here. So as you can see, when we want to find the gradient x equals to 2, I've marked with the green dot. And if we differentiate this, we'll get a linear graph. And that linear graph will show us the gradient at that point. So when x equals to 2, our gradient is 11, as seen there. Number 2, find the gradient of the curve f of x equals to 2 over 3x cubed plus 1/2 x squared plus x at the point x equals to 1. So same steps, differentiate. And that should give you 2x squared plus x plus 1. And then again, it's just substitute and solve. So this should give you 4 as your gradient. And once again, got a few pictures. So we have a cubic here, and that's our original function. And we want to find the gradient at x equals to 1. And if we differentiate that, we'll get to our parabola. And as you can see, at our parabola, we've got when x equals to 1, our gradient equals to 4, as you can see. So now we're going to, our next skill, that's just achieve level questions, but now we can find equation of tangents at a point. That's our second skill. A tangent to the curve is a straight line that cuts the curve once at the specific x point. Alright, so a tangent meets, what am I doing? A tangent measures the gradient at a point. So basically, if I draw a line on a parabola and it touches the parabola once, it's basically measuring the gradient of that parabola at that point. The tangent equation is a straight line. Okay, a tangent is a straight line, so it's in the form y equals to mx plus c. And our steps in doing these questions is differentiate and find the gradient at x point. So that's what we just did before. And once we found that gradient, that is our m value in our equation. That's our gradient. And step number 2 is we have to use that y value at that x point. This is normally it's given, but sometimes you have to manually go find it. And you can manually find that y point by substituting the x point back into the curve equation. And number 3, you can solve for c and rewrite the equation. And I've got a little picture here to depict what I'm talking about. So you have a parabola, and then you have that equation of a tangent, which is a green line that touches the point once, which is shown by the black dot. It touches it at x equals to 2. So therefore, it's measuring the gradient of the parabola at x equals to 2. So we have our examples here. Find the tangent of a curve y equals to 3x squared plus 2x plus 3 at the point x equals to 2. Alright, so we're going to follow through with our steps, differentiate, and we're going to find that our derivative is equal to 6x plus 2. And next, we're going to find the gradient at this point. So basically, when I was saying, we're going to find our m value, okay, the m value of our straight line. We're going to substitute 2 into the equation, and we should get our answer to be 14. So now we can, okay, so this time around, I didn't give us the y point, so now I have to go manually find the y point. Because the curve touches the tangent, that means when the curve equals to something, that tangent will also equal to that, because it's touching, it's at the same place. So therefore, we can substitute x equals to 2 into our curve, and we'll find that that point is actually y equals to 19. And now we can use y equals to 19 to find our c value for our tangent. So we now know that y point, and we know our x point. So our x point is 2 and our y point is 19. So therefore we can substitute to find our c. 19 equals to 14 times of 2 plus of c. So therefore c equals to -9. And once again, we're going to rewrite our final equation. It is crucial that you do this because sometimes the examiners won't give you the full mark if you do not rewrite the final equation now. Okay. So we're going to rewrite our final equation, and it's going to be y equals to 14x minus of 9. And I've got a little image here just to show what I mean. So at the point 219, the tangent line touches the parabola, okay? The tangent line is touching, and that parabola is also at that same place, 219. And what we just found, 14x minus 9, is the equation of that tangent line. So we have a more difficult example. So this is a past NCA example. This is an excellence question. So tangent to a point of the function y equals to -3rd of x cubed plus kx plus 4 at a certain point p has a gradient of -7 and intersects the graph again at -664. Use calculus to find the coordinates of point p. Alright, so with this question, they it does mention that there's a certain point P that they touch, and there's also a point of -664 that they touch. So basically, I didn't actually get a photo, an image for what I'm talking about, but basically imagine a parabola, and a straight line cuts through and just cuts through a point on the left and a point on the right. So it cuts through twice. Alright, so some key information to note down already. They've already told you the gradient. That's the gradient of the tangent line has already been told to be -7. So it tells you the gradient is -7, so you can write down that your m is equal to -7. Okay, so using this information, we know gradient is -7, and we also know that the tangent line passes through the point -664. And now we know our x and our y value, we can find our c value of our tangent line. So we see here that y equals to mx plus c, and we know when x equals to -6, y equals to 64. And we also know that the gradient is -7. So using this information, we can find our c value. So we should see 64 is actually equal to -7 times of the -6 plus of c. So a negative times a negative is a positive, so 42 plus c equals to 64, so therefore c equals to 22. So now we know the equation of our tangent line, okay? So our tangent line is y equals to -7x plus of 22. Alright, so another missing piece of information is the kx. As you can see, the in our graph, we have y equals to negative 1/3 of x cubed plus kx. So we have this missing piece of information. We don't know our k value. However, using the information given once again, it says the tangent to the graph intersects the graph again at negative 664. So this negative 664 is intersecting the graph. So basically, the graph also passes through negative 664. So if we substitute 64 and negative 6 into our graph equation, we can find for what our k value is. So basically, the tangent intersects the graph at negative 664. Hence, the graph passes through this point, like I was just saying. So we can use this to find our k value. So therefore, 64, our y value, equals to negative 1/3 of negative 6 cubed plus negative 6x plus 4. So minus 6x plus 4. I haven't done the working for this question, but negative 6 cubed should be negative 216, and a negative times a negative is a positive, so it should be along the lines of 64. No, not quite. But it's just simple rearranging the equation. Our next step to find the point of intersection to make the tangent equal to the graph. The tangent touches the graph, hence they're equal at these 2 points. So what I'm trying to say is, you know that the graph and the tangent line touches twice, and they're giving you 1 point and they didn't give you the other point. However, you know that because they're touching, they're actually equal to each other at these points. So if you make the graph equal to our tangent line, so you make the graph equals to the tangent point, you can find both of the points where the graph and the tangent are touching each other, and that is our point P we want. So basically, what we're trying to do is our negative 1/3 of x cubed plus of 2x plus of 4 equals to negative 7x plus 22. And we move the negative 7x, and we move the 22 to the other side. We make it equal to 0. And all you have to do is press some buttons into your graphics calculator. So you should go polynomial and degree should be 3, because our highest power is 3. So degree 3, and we type in our numbers. We type in a equals to negative 1/3. We don't have a b value because b would be x squared. We don't have any x squared, so b equals to 0. If we move the negative 7 over, it's positive 9x, so our c value is 9. And if we move the 22 to the other side, it's minus 22, so our c value is negative 18. So by doing this, you press the enter button, you should get your answer as x equals to 3 or x equals to negative 6. Alright, note down that we were already given our point negative 664. So therefore, we can conclude that our point P is x equals to 3. So now we can substitute 3 into our tangent graph or the graph to find the y point. The reason I say we can do it to any one of these is because, like I was saying, these two are equal at this point. So it doesn't matter whether you substitute into your graph or your tangent point, you will get the same answer. However, since the graph has all this x cubed, x, and x, it's a lot harder to do that. So I'm rather substitute into the gradient, because that's only 1x. So that's only negative 7x plus 22. It's a lot easier. So if we substitute, we should get negative 7 times 3 plus 22, and that should give us our y value is 1. So therefore, we can conclude that our point is 3, 1. However, we always need a justification. So what our justification will be at this time will be proving that the gradient is negative 7 at this point, okay? So basically, we need to justify, so we need to prove that the gradient is negative 7 at point equals to x equals to 3. So if we differentiate our graph, the original equation we had, we should get negative x squared plus 2. And if we substitute x equals to 3 into this equation, we should get negative 9 plus of 2. So 3 squared is 9, negative 9 plus 2. And that does equal to negative 7. So therefore, we've proved that the gradient is negative 7 at this point. So that's your question finished, and that's an excellent grade there. So our next point we're going to be covering is our maximums and minimums, okay? So basically, at a maximum or minimum, the gradient is 0. This is because there's a temporary stop in the graph. So when I say a maximum, okay, it's like that point, that vertex point on a parabola, or that vertex point on a cubic that the graph has temporarily stopped. So if I draw a tangent line there, it will go, the tangent equation of the tangent will be 0x plus or minus something. So all maximum and minimum questions require you to substitute the gradient as 0 and solve. So you know that the gradient is 0 in the maximum minimum, so you know the gradient equals 0. So mainly what you're going to do in these questions is differentiate a function, substitute the substitute the gradient equals to 0, and then solve for something. Alright, so a maximum is when a graph hits a point where after the point the gradient is negative, and a minimum is where the graph hits a point where after the point the gradient is positive. I think I do have a picture here. So we've labeled the maximum and our minimum for this cubic. So as you can see, there's a maximum on the left hand side, and after that maximum the graph starts sloping downwards. Again with the minimum, after that minimum the graph starts sloping upwards. So I also want to mention the second derivative test. Okay, so the second derivative test is used to determine whether a point is a maximum or a minimum. Alright, so first thing we've got to do is we need to find the x points that a minimum or a maximum occurs, and then we have to differentiate the function again. Okay, and substitute these x points that a maximum or minimum occurs. We're going to substitute that into the second derivative. If the result comes out to be the negative, then it must be a maximum turning point, and if the result is a positive, then it is a minimum turning point. And I've got three graphs here. So we got our blue graph is our f of x, differentiated once is our parabola, which is the f dash of x, and if we differentiate again, the red graph, our linear graph, is our second derivative. So, some examples. The function f of x equals to 3x squared plus bx plus 3 has a turning point at x equals to 1.5. Prove using the second derivative test the nature of the turning point while finding b. Okay, so a lot of people have trouble understanding what nature of a turning point means, but you can do that. Literally just means whether this is a maximum or a minimum. There's nothing else to it. So we're just gonna differentiate this normally. So another thing that students have a lot of problems with when they see a bx or an ax squared or something that's not a number, they start panicking and they don't know how to differentiate. However, it's the exact same process. Okay, so there's no need to panic. This is the exact same process of differentiation with our power rule. So we should get 6x plus of b. Alright, so we know that the turning point at x equals to 1.5, and we also know the gradient at this point is 0. So we can substitute gradient equal to 0 and our x equals to 1.5. So we know that 0 equals to 6 times of 1.5 plus of b. So therefore we can find out that our b value is actually negative 9. Okay, so now we found the point b, but now we need to determine the nature of the turning point. So we can do that by using the second derivative test. So we differentiate again. That's f double dash of x, so that's differentiated twice, and that should only give us a 6. Okay, so this is another problem that students have. When they use the second derivative test, they see the 6 with no x, and they start panicking. Oh, where's the x? I can't substitute anything in, so what do I do? However, because there are no x terms, therefore there is no substitution needed. So therefore 6 is our answer, and 6 is positive. And back to our previous notes, we know if it's positive, then therefore there has to be a negative turning point. And that will be your final answer for this question. I did draw a graph here, so as you can see, this f of x is actually a parabola, and the parabola has its vertex or its lowest point at x equals to 1.5, which we found. So we have a more difficult example. So we have the function f of x equals to x cubed plus bx squared plus 2x plus 8 has turning points at x equals to 2 and x equals to 4. Find a and b, and therefore the nature of the turning points. Okay, so the way we're going to approach this question is the exact same as we did in the last question, except for this question, we do need to use a bit of simultaneous equations, okay? So it is a bit harder. So once again, we're going to differentiate normally, okay? Do not let the ax cubed or bx squared, it doesn't matter, okay? Exact same thing. So if we differentiate normally, we should get 3ax squared plus 2bx plus 2. And if we use our simultaneous equations, because we know it has turning points at x equals to 2 and x equals to 4. And when I say turning points, that means the gradient at these 2 points are 0. So basically 0 equals to x something something, and 0 equals to 4x something something something, okay? If we use simultaneous equations, we should get that 0 equals to 12a plus 4b plus 2, and 0 also equals to 48a plus 8b plus 2. So basically, the top equation is substituting x equals to 2, and the bottom equation is substituting x equals to 4. And now we can just use our simultaneous equations. This is pretty easy simultaneous equations here, so the numbers fit pretty nicely. So simplify and solve. So there is a little bit of algebra here. Okay, so the algebra, I multiplied the top function by 2, so that becomes 24a plus 8b plus a 4, and I did 48a plus 8b plus 2 minus 2 times of the top graph, and that should give us the 24a minus 2 equals to 0, and therefore a equals to 1 over 12. So this is just simultaneous equations in the algebra. So therefore we know a equals to 1 over 12, so we substitute a equals to 1 over 12 into our equation, and we should find that our b value is negative 3 over 4. So we find the a and b, but now we need to find the nature of the turning points. And once again, we need to do the the second derivative test here. So we're going to use our so first we're going to rewrite the equation because we found our a and our b values, but it's a bit confusing right now because we don't have the f dash of x equation. So we can substitute our a back into our equation and our b back into our equation as numeric values. So therefore we can find that our f dash of x equals to 1 over 4x squared minus 1.5x plus of 2. And that's basically just by putting 3 times of 1 over 12. 3 times of 1 over 12 is 3 over 12, and that's 1 over 4. And if we put negative 3 over 4 as our b, 2bx, so 2 times of negative 3 over 4 is 6 over 4. Negative 6 over 4 is negative 1.5. So that's basically how I got that equation. So we rewrite the equation, and then we find the second derivative, so differentiate again. And we should find that our second derivative is 1/2 of x minus 1.5. So now there is an x value, so therefore we need to substitute our x values to find which one's the maximum and which one's the minimum. So now we just justify whether it's a maximum or minimum. So f double dash of 2 gives us the answer as negative 0.5. This is a negative, so therefore it's a maximum. For f double dash of 4, it comes out to be positive 0.5. Positive 0.5 is a positive number, so therefore this is a minimum. And that will be your full answer to this question. This is definitely an excellence level question. And I've got a little image to prove it. So we had our 4. We had our x equals to 4 is on the right, and our x equals to 2 is on the left. So x equals to 2, we found out that was a maximum turning point. So as you can see, it is a maximum turning point because it is how do I say it? So after the point, the gradient is negative. And our x equals to 4, we know is a minimum turning point because after x equals to 4, the gradient becomes positive again. Another example, so the function f of x equals to 2 over 3x, whole thing multiplied by x cubed plus 7x squared plus 10x plus 3. We'll find the turning points and the nature of those turning points. Alright, so first thing we've got to expand. Okay, so right now we have pretty nasty numbers. We have to expand to get to our normal equation that we can differentiate. So we should get our differentiation should be 2 over 3 x to the power 4 plus 14 over 3 x to the power 3 plus 20 over 3 x squared plus 2x. And that's our f of x, and now we can differentiate. Just differentiate normally, so that's just f dash of x equals to 8 over 3 x to the power 3 plus 14x squared plus 4 over 3x plus of 2. Alright, so once again, we're following the exact same processes here. So we're going to make the gradient equal to 0 because it's a turning point. So 0 equals to all of that. Okay, so in this time, once again, we're going to go to our graphics calculator. We're going to press degree 3 because our highest power is 3. And we're going to enter our a value is 8 over 3. our B value is 14, our C value is 40/3, and our D value is 2. And if we click that into your calculator, you should get your x points, or your x value should get to be -1, -0.184, and -4.07. Alright, so now we need to find the nature of the turning point. And once again, we follow the exact same process. We're going to find the second derivative. So if we find our second derivative test, f double dash of x is 8x squared plus 28x plus 40/3. And we're just going to substitute these points in one by one to see which one is the maximums and which one is the minimum, okay? If we do f double dash of -1, we should get our answer to be -6.67. This is a negative number, so this is a maximum turning point. We're going to substitute f double dash of -4.07, and your answer should come out to be 31.89. This is a positive number, so therefore -4.07 is a minimum turning point. And if we substitute the -0.184, you should get your answer as 7.91, which is positive, and therefore it is a minimum. And I've got a little bit of, I'm sorry, I don't think you can see this very clearly, but if you can't see, we have our -4.066, which is rounded. That is our minimum point, as you can see at the very bottom here. And if we go up to our x equals to -1, that is our second dot. That's the dot in the middle. That's the black dot in the middle, and that is actually the maximum turning point as we justified. And coming up to the rightmost black dot, that is our -0.184, and that is another one of the minimum turning points. So some applications of maximum minimums, so these application type questions will come at the exam very often. So an easy example would be, Kevin is saving some money in the bank. The function that represents the money he has at t time is modeled by s of t equals to 3t squared minus 15t plus of 9, where s is the amount of money he has in hundreds of dollars. Find the minimum amount of money he has. Alright, so as soon as you see the words turning point, minimum, or maximum, the first thing that should come to your mind is gradient equals to 0. Okay, so once again, we follow through with our steps. We differentiate, and we should get our s dash of t equals to 6t minus 15, and once again minimum. So therefore, gradient equals to 0. So we can find our turning points, or in this case, it's just one turning point, which is t equals to 2.5. And now this is our graph. Okay, so this is our gradient function, and our gradient function, as you can see, when t equals when whatever equals to 2.5, the gradient equals to 0, as you can see. So it doesn't actually say in this question to prove, but it's always good to prove. So we prove this is a minimum by the second derivative test. S double dash of t is 6. So therefore this is positive, and therefore this is a minimum. And now we need to find the minimum amount, okay? Because in the question it says find the minimum amount of money he has. So now you already know that the minimum occurs at 2.5. When t equals to 2.5, our minimum amount occurs. So therefore, if you substitute the t of 2.5 back into the equation, you can find the minimum amount of money he has. So now, it's basically just a matter of substitution. So if we substitute 2.5 into the equation, we'll get our value to be 0.25. But note down the question says it is the amount of money he has in hundreds of dollars. So therefore, we have to multiply our final amount by 100 to find the final answer. So if you make a concluding statement here, our concluding statement we can say is Kevin has 0.25 times of 100 equals to $25 as the minimum. And I have a little parabola to prove this. Okay, so the minimum occurs at 2.5, x equals to 2.5, and at y equals 0.25. Now I have a bit more of a difficult example here. So this is a past NCEA paper. So a rectangle ABCD measures 8 by 10. A parallelogram EFGH can be drawn inside the rectangle as shown in the diagram below. Suppose the distance from each corner of the rectangle to the next vertex of the parallelogram in the clockwise direction is x centimeters. That is AE equals to BF equals to CG equals to DH equals to x. Use calculus to find the smallest possible area that the parallelogram can have. Justify your answer as a minimum. Alright, so the first thing you got to do, because it asks us what is the smallest possible area that the parallelogram can have. So we need to model an equation for the area of the parallelogram. So we can model our equation for a parallelogram. We can say that the area of the parallelogram equals to the area of the rectangle minus all the triangles you can see there. So we can immediately see that the area of the rectangle is 8 by 10, so area of the rectangle is 80 centimeters squared. But now we need to find the area of the triangles there, okay? So area of the triangles. So we're going to label our sides. We know that this whole side is 10 centimeters, and that one part of that side is x centimeters. So the remaining side must be 10 minus x. And this is the exact same for the other side. We know the entire side is 8 centimeters, and we know that that one little side must be x centimeters. So therefore, therefore we know that that little side there is 8 minus x centimeters, okay? And that's the exact same for both the other sides there. So by writing our equation, okay, we can say the area of the triangle equals the half base times height. So for example, if you're looking at the triangle AEH, okay, so let's look at that triangle. So 8 minus x times of x divided by 2. But as you can see, we also have GFC, triangle FGC. And that triangle is also x times of 8 minus x divided by 2. So therefore, there are two of the same triangles. So therefore, the 2 cancels each other out. And that's exactly the same with the 10 minus x and the x. So it's exact same with the other two triangles there. So we find our area of the triangles, and we're going to simplify this equation here. So area of the triangles we can simplify equals to negative 2x squared plus of 18x. And therefore we can substitute back into our original parallelogram equation. So area of the rectangle minus area of the triangles. So area of the parallelogram equals to the area of the rectangle minus the area of the triangles. Double negative makes a positive. So 80 plus of 2x squared, negative and a positive make a negative. So 80 minus 18x. That is our equation for our parallelogram. And now we're going to differentiate, and because we want to find the minimum, find the turning points. So a dash of x is 4x minus 18. Make gradient equals to 0. You should find that your x equals to 4.5 centimeters. And our final step is to, well, not our final step, but our next step is to substitute 4.5 back into the original area equation to find the minimum area. And that is 39.5 centimeters squared. And our final step is to justify that the answer is a minimum. And so once again, justify means second derivative test. So not f in this case. In this case, a double dash of x equals to 4. 4 is a positive number, so therefore this is a minimum turning point. And by doing all of this, you'll get your excellence level. You'll get your excellence grades there. Alright, so I'm going to stop the video here. I'm going to cover increasing, decreasing functions, and some drawing different graphs in the next video. So this video is getting a bit long. Alright, see you in the next one, guys.